Hello everyone. In this video we will talk about one of the important topics in probability, that's called conditional probability and the multiplication rule. There are some pointers in today's lecture that we will talk about it. The first one is determining the conditional probabilities. What are the conditional probabilities? Second one is distinguishing between independent and dependent events. Then we will talk about the use of multiplication rule to find the probability of two events occurring in sequence. And then we will talk about the use of multiplication rule to find the conditional probabilities. Those four main topics are today's lecture's main topics. The first one is conditional probability. Conditional probability is the probability of an event occurring given that another event has already occurred. So in most of the cases we will have two or more events happening at the same time. So we should find that the first event is related to the second event or not. Or we can say the second event is dependent on happening of the first event. Denoted with P, B/A. So P is the probability, B is the second event, A is the first event. So we can read it like this. Probability of B given A. So means A will happen firstly and then B will happen. So we have to find if the happening of B is dependent or independent to happening of event A. We have an example. Two cards are selected in sequence from a standard deck. So a standard deck consists of 52 cards. We have to know this. Find the probability that the second card is a queen given that the first card is a king. Assume that the king is not replaced. So we have two events that has been happening. The first one is drawing a king card. The second one is drawing a queen card. So we have to find the probability of happening the second event, that is a card with queen. Okay, so because the first card is a king, the first card that has been drawn is a king and it is not replaced. So we have 52 cards. When you draw a card, so 51 cards will be remained on the deck. So the remaining deck cards are 51 cards. Okay, 4 of which are queens. So the first card that has been drawn is or was a king. So it means we have 4 queens has been remained in the 51 cards. So the probability B/A means the probability of the second card to be a queen, okay, slash the probability of the first card to be a king, okay, probability of B/A. Probability of B means probability of happening the second event. In our case, the second event is drawing a queen card. So drawing a queen card is 4, because we have 4 queens, divided by 51. Why 51? Because the first card has been drawn and not replaced. So this is why we have 51 cards left on the deck. So 4 divided by 51 will be equal to 0.078. In the next examples, we may have happening two events at the same time or in sequence. So we have another example, finding the probability of something in a group of data. Now we have a group of data in a form of table. The table shows the results of a study in which researchers examined a child's IQ and the presence of a specific gene in the child. So we have two variables. The first variable is the child's IQ, and the second variable is the presence of a specific gene, okay, in the child. So find the probability that the child has a high IQ given that the child has the gene. So when you select a child in this group of people, so what's the probability of selecting a child with a high IQ and at the same time having this specific gene in the child? So there are 72 children who have the gene. So we have 102 children, but among those children only 72 children have the gene or this specific gene. So among this 72 we have 33 children with a high IQ and we have 39 children with a normal IQ. So how can we solve it? The probability of choosing a child among this group with this specific gene and with a high IQ. Of these, 33 have a high IQ. So probability of B/A. B means probability of choosing a child with a high IQ. A is the first event with the presence of a specific gene. So we have 33 children with a high IQ divided by the total number of the children with the gene. Okay, so 33 divided by 72 will be equal to 0.458. So this is the probability of choosing a child among this group of children with a high IQ and presence of a specific gene. Independent and dependent events. So we have this topic that is very important to understand the probability of different events. Independent events means the occurrence of one of the events does not affect the probability of the occurrence of the other event. So it means we have two events and those two events are independent on each other. The occurrence or happening A will not affect it of happening B. So it means those two events are completely separated from each other. In the form of formula, we can denote independent events like this. Probability of happening B/A will be equal to probability of B, or probability of A/B will be equal to probability of A. What does that mean? In the first case, okay, probability of B/A means B is not dependent on A. Those two events, A and B, are independent on each other. So it means they are separate from each other. So this is why it is equal to probability of B, because A has no effect on B. And in this case, probability of A/B is equal to probability of A. What does that mean? Means probability or happening B has no effect on A. So this is why probability of A related to B or probability of A in relation to B is equal to PA. So it means B has no effect on happening A. Events that are not independent are dependent. What does that mean? Means we have some events that are related to each other. Happening, one of them is related to the happening of the other. So they have a connection, they have a relation to each other. So these kind of events are called dependent events. In words, if the probability of B given A is still calculated as the probability of B, then A has not affected B. Therefore, B is independent of A. Okay, so as a double check, we can calculate the probability of B. Okay, probability of B can be calculated, and then probability of B given A can be calculated. If the results are the same, so it means those two events are independent of each other. For example, the probability of rolling a 5 after flipping a heads. Okay, rolling a 5 is not affected by whether the coin is heads or tails. So rolling a 5 is not affected whether the coin is heads or tails. So there is no relationship between the coin and the die. So this is why those two events are independent of each other. Now we have some examples that we can distinguish between independent and dependent events. Number one, we have to decide if these two events are dependent or independent on each other. Selecting a king from a standard deck. Okay, selecting a king from a standard deck. This event is denoted with A. Not replacing it, and then selecting a queen from the deck. Okay, selecting a queen from the deck, so we denote it as B. So we have to find if those two events are dependent or independent. Probability of B/A. B is the probability of happening the second event. A is the probability of happening the first event. Okay, the second event is selecting a queen. The first event is selecting a king. And the king will not be replaced. Okay, so BA will be equal to 4 divided by 51. Okay, 4 means we have 4 queens in among the cards. And also this 51 denotes the number of cards. But why we use 51? Because we selected the first card and we didn't replace the card. So this is why we have 51 cards on the deck. So the probability of happening B in relationship to A is equal to 4 over 51. Now we have to calculate the probability of happening B alone. Now probability of happening B, choosing a queen, okay, among the 52 cards, so is equal to 4 over 52. Now we know that 4 over 51 is not equal to 4 over 52. So this is why those two events, A and B, are dependent on each other. We have another example. Tossing a coin and getting a head. This is the event A. And then rolling a 6-sided die and obtaining 6. This is the event B. So we have to find if those two events are dependent or independent on each other. Probability of B happening A means probability of rolling a 6, okay, happening or having a head on a coin. So whatever the coin is, we will have one possibility of happening the probability of B. Means probability of B is equal to 1 over 6. Okay, if the coin is head or tail, we only have 1 6. So the probability of having a 6 on the 6-sided die will be 1 over 6. This is the first case. The second case, probability of happening B without regarding to the coin. So probability of B equals to probability of rolling a 6 is simply equal to 1 over 6. Since probability of B is equal to probability of B slash A. So as you see, those two numbers are equal, 1 over 6 and 1 over 6. So those two events are independent on each other. We have a multiplication rule for calculating those events that will happen together or in sequence. Multiplication rule for the probability of A and B. The probability that two events A and B will occur in sequence is probability of A and B will be equal to probability of A multiplied by probability of B slash A, because A will happen first. Okay, so this is why we will write P probability of A, and B will happen second. So this is why there is a possibility that B is dependent on A. This is why we should write probability of B slash A, and we should change and to a multiplication. This is a rule that will be used and valid for all the events that will happen in sequence. For independent events, the rule can be simplified to PA and B will be equal to PA multiplied by PB. So in this case, there is no relationship between event A and event B. Now we will have an example for using this formula. Two cards are selected without replacing the first card. In a deck card, we have 52 cards. Two cards has been selected without replacing. From the standard deck, find the probability of selecting a king and then selecting a queen. Okay, let's find it. Because the first card is not replaced, the events are dependent. You have 52 cards. When you selected the first card and you are not going to replace it, so the number of the cards will be changed. For this reason, these two events are dependent on each other. Probability of having a king and having a queen equals to probability of having a king multiplied by probability of a queen, but the queen should be written like this: PQ slash K. Why? Because Q is dependent on K. Okay, the first term, probability of having a queen, is equal to 4 over 52. We have 4 kings and 52 cards multiplied by, for the queen we have 4 queens divided by 51, because in this case only 51 cards are left on the deck. So when you multiply those two numbers, we will have 16 divided by 2652 and is equal to 0.006. Another example is a coin is tossed and a die is rolled. Okay, we have two events, and we know that those two events are not dependent, they are independent events. Find the probability of getting a head and then rolling a 6. Let's see how can we solve it. The outcome of the coin does not affect the probability of rolling a 6 on the die. These two events are independent, they are separated. So PH and 6, okay, equals to PH multiplied by P6. For the heads, we have one head and two possibilities, so 1 divided by 2. And for the 6, we have 1 6, okay, and we have 6 possibilities, so this is why we divide 1 by 6. So the result will be equal to 1 over 12 and is equal to 0.083. We have another example that is more realistic. The probability that a particular knee surgery is successful is 0.85. Find the probability that 3 knee surgeries are successful. Okay, the probability that each knee surgery is successful is 0.85, and the chance of success, or the chance for success for one surgery, is independent of the chances for the other surgeries. The other surgeries are not related to each other. So this is why the probability of one surgery is not affected by the other surgeries. Three surgeries are successful means the probability of the first surgery multiplied by the probability of the second surgery multiplied by the probability of the third surgery. So the rate of success of each of these surgeries is 0.85. So we will multiply 0.85 by 0.85 by 0.85. So the result will be 0.614. This is the possibility or the probability of the success of all the knee surgeries at the same time. For the same example, we will have another requirement. Find the probability that none of these three surgeries are successful. So how can we solve it? Because the probability of the success for one surgery is 0.85, so the probability of failure for one surgery is equal to 1 minus 0.85. It means the probability of failure of one surgery is equal to 0.15. So the probability none of the three surgeries is successful, okay, means the probability of the first surgery to fail multiplied by the probability of the second surgery to fail multiplied by the probability of the third surgery to fail. And the result will be 0.15 multiplied by 0.15 multiplied by 0.15. That's equal to 0.003. Another requirement for the same example. Find the probability that at least one of the three knee surgeries is successful. What's the meaning of at least one of the three? At least one means one or more. We have one surgery that's successful, or two surgeries, or three surgeries. The complement to the event, okay, of at least one is successful is the event none are successful. None are successful is equal to at least one. Okay, when you have at least one in a group of trials, okay, at least one means the complement of this event is equal to none are successful. Okay, none are successful. How can you calculate it? P at least one is successful, okay, equals to 1 minus P none are successful. Now we know the probability of none of the surgeries to be successful. In the previous slide we calculated. So 1 minus 0.003 is equal to 0.997. This is the probability of at least one of the knee surgeries to be successful. We have another example. A US roulette wheel has 38 numbered slots, 1 through 36, 0 and 00. Of these, 18 are black, 18 are red, and 2 are green. A dealer spins the bell one direction and the wheel the other. The ball can land with equal and independent probability on any one of 38 numbered spots. Okay, so what is the probability of the ball landing on red twice in a row? This is the question. Okay, so there are 38 possible choices. We have 38 possible choices with 18 red. So the question is about landing on red twice. So we have 18 reds. Therefore, the probability of landing red is 18 divided by 38, or 9 divided by 19. Doing it twice in a row would be 9 divided by 19 multiplied by 9 divided by 19 equals to 81 divided by 361, or 0.224. This is the probability of landing on red twice in a row. Now you can find the probability of any of the colors. So what's the probability of landing green twice in a row? We have two greens, 2 divided by 38 multiplied by 2 divided by 38. Another example is, according to the National Hurricane Center, the probability of Florida getting hit by a hurricane in a single year is 5/19. This is the probability of having or happening a hurricane in Florida in a single year. So we have 3 questions for this case. What is the probability of getting hit by a hurricane 3 years in a row? The second question is, what is the probability of not being hit by a hurricane in the next 10 years? The third question is, what is the probability of getting hit at least once in the next 10 years? The first question, the probability of happening hurricane in the next 3 years means the probability of hurricane and the probability of hurricane and the probability of hurricane. So we will change all these ands to multiplication. Probability of hurricane multiplied by hurricane multiplied by hurricane. So the probability of happening a hurricane in 1 year will be multiplied by the probability of happening of hurricane in the next year, and the result will be 5 divided by 19 multiplied by 5 divided by 19 multiplied by 5 divided by 19, and the result will be 0.018, that's equal to 1.8. The second question is probability of happening no hurricane in the next 10 years. First of all, we will find the probability of happening no hurricane in 1 year. In 1 year, 1 minus probability of happening hurricane will be equal to 1 minus 5/19. So will be equal to 14/19. This is the probability of not happening a hurricane in 1 single year. So in the next 10 years in sequence, we will use the multiplication rule for the first year multiplied by the second year multiplied by the third year. So the result will be 14 divided by 19 with the power of 10 will be equal to 4.7%. 4.7% is the probability of happening no hurricane in the next 10 years. The third question is the probability of happening at least one hurricane in the next 10 years. So probability of happening no hurricane in the next 10 years is equal to 4.7%. So happening at least one means 1 minus no hurricane. Okay, 1 minus happening no hurricane will be equal to 1 minus 0.047 and will be equal to 0.953. This is the probability of happening at least one hurricane in the next 10 years. That is equal to 95%. This was about the probability for the natural disasters that may happen in the future. We have another example. In this example, we have a chocolate covered with cherries. Okay, you love chocolate covered with cherries. Okay, there are 5 in a box of 20 tablets. So we have 20 chocolates in a box. 5 of them are covered with cherries. Okay, so what's the probability that you will get 2 in a row? Okay, you will get 2 chocolate covered with cherries in a row. For the first cherry, the probability is simple, that's equal to 5/20, because there are 5 chocolate covered with cherries, and the total number of chocolates are 20. So the probability for the first trial is equal to 5 over 20. Okay, this is for the first trial. The question is about having 2 in a row, means we will have 2 trials. What about the second cherry? Now for the second cherry, okay, you ate the first cherry, so this is why only 4 of the chocolate covered with cherries is left in the box. This is for the cherries. And also the total number of the chocolates was 20, but now you ate one of them, so the total number is decreased to 19. Therefore, the probability of getting a cherry for the second trial will be 4 over 19. 4 over 19. Since the question is asking having a cherries 2 times in sequence, so we will use the multiplication rule for this case. We can multiply the probability of having 1 cherry in the first trial multiplied by the probability of having 1 cherry in the second trial. In the first trial we have 1 over 4. In the second trial we have 4 over 19. So the result will be 1 over 19. This is the probability of having 2 cherries in a row in a box with 20 chocolates and 5 chocolates covered with cherries. As a summary for this lecture, in this lecture we determined the conditional probabilities. What are the conditional probabilities? And we distinguish it between the dependent and independent events. And also we used the multiplication rule to find the probability of 2 events occurring in sequence. Then we used the multiplication rule to find the conditional probabilities. Those 4 main pointers are the summary and the main topic is that has been discussed in this lecture. Thank you very much for asking questions. We will have an online meeting maybe 2 weeks later.